Can you imagine an invisible line in the ocean, one that animals, birds, and even fish almost never cross? This strange boundary separates animals from two completely different worlds, just a few kilometers apart. On the west side, you'll find animals like elephants, tigers, and woodpeckers, typical Asian wildlife. But just across the line, you enter a different universe, with kangaroos, koalas, and giant lizards. The Wallace Line is named after Alfred Russel Wallace, a curious nature explorer. He noticed how animals were completely different on each side, even though the islands were neighbors. Let's rewind to April 18, 1854, when Alfred Russel Wallace, a young naturalist, set out on an epic expedition to the Malay Archipelago. He had just joined his family's land surveying business and had partnered with the entomologist Henry Walter Bates to collect rare specimens. His journey began in Singapore, but due to a missed ship to Sulawesi, he ended up in Bali. While there, he started collecting specimens and studying the local biodiversity. But then, something astonishing caught his attention. On visiting a nearby island, Wallace noticed an entirely different set of species, including monitor lizards and kangaroos. How could this be? These islands were barely 35 kilometers apart. Over the next 8 years, Wallace meticulously explored the Malay Archipelago. He observed that certain birds, especially non-migratory ones, could only fly short distances in search of food. That meant they couldn't cross even a modest 35 kilometers sea gap. For underwater creatures, strong ocean currents acted as invisible walls. From this, he proposed a groundbreaking theory, an invisible boundary, now famously known as the Wallace Line. This line runs through Indonesia, separating islands like Borneo and Sulawesi, and Bali and Lombok. Even though these islands are geographically close, their ecosystems are drastically different. For instance, birds such as the yellow-headed weaver and the Javanese three-toed woodpecker were common in Java and Bali, but completely absent in Lombok. Wallace believed that geological factors played a key role in the distribution of species. He suggested that ancient geological events shaped how animals evolved and spread, pioneering a new scientific field known as biogeography. Wallace theorized that islands west of the line, like Bali, were once connected to the Asian mainland. That's how large animals like tigers and rhinos could have made it there without crossing deep water. Conversely, he proposed that the islands east of Java and Borneo were remnants of an ancient Australian continent. Though Wallace lacked the concept of plate tectonics, he wasn't far off. By the 1980s, scientists confirmed that Wallace's invisible line had a geological basis. It separates two ancient supercontinents, Sunda in the west and Sahul in the east. These two were much farther apart during the ice ages, and only drifted closer over millions of years. This explains why the islands on either side evolved unique species. For example, the Komodo dragon first appeared in mainland Australia and reached its current home about 1 million years ago. Just east of the Wallace Line lies Wallacea, a chain of volcanic islands never part of any major continent. Most of the colonizers came from the Australian side. Even today, deep-sea channels still act as biodiversity barriers. For example, the 35 km wide Bali Lombok Strait is a hotspot of divergence due to deep ocean currents. But here's the twist that history almost buried. In 1858, Wallace sent his theory of evolution by natural selection to Charles Darwin. While Darwin published On the Origin of Species, Wallace's contributions went mostly uncredited. Wallace's name was left out, and Darwin was hailed as the father of evolutionary biology. Despite identifying over 125,000 plant species and 1,500 insect species, Wallace died with little recognition. It took more than 50 years after his death for the scientific community to realize he had been right all along. Today, we know that Wallace's line isn't just an invisible boundary, it's a portal into Earth's ancient past, shaped by tectonic forces, deep ocean currents, and evolutionary paths separated by time and terrain. So, what's your take on this? Had you heard of Wallace's contributions before? Did you know Darwin's success partly came from Wallace's observations? Tell us in the comments, and don't forget to like, share, and subscribe.